Today we are going to solve the numerical problems related to gravity, gravitation, acceleration due to gravity and weight of the body. But certain formula is needed for it, and first I want to start with the formula which are essential for the solution of the numerical problem related to these physical quantities. Okay, let's start. Look at this. F equal to g m1 m2 by d square, F equal to g m by r square, small g equal to capital G capital M by r square, g dash equal to g m by r plus h whole square, and w equal to mg. These are the formula which we use to solve the numerical problem. The condition of use of this formula: if two bodies having mass m1 and m2 are separated by a distance d, then we'll use this formula to find the gravitational force between them. In this case, m1 and m2 are given and distance between them is declared and force of gravitation between them is asked. But what about capital G? Capital G is a gravitational constant. Its value may or may not be given in the numerical problem. If given, then we'll use that, and if not given, then we have to put ourselves 6.67 into 10 power minus 11 Newton meter square by kg square. Now let's talk about this second equation, F equal to capital G m by r square. This is same as the previous equation. Just in place of m1 we are writing capital M, in place of m2 we are writing small m, in place of d we are writing r. Basically these two equations are same, but in which condition it is used? Actually, if we have a huge heavenly body and a body is lying on its surface, and this is the radius of the huge heavenly body, let's say this is earth, then mass of the earth can be taken as capital M, and a body lying on its surface, its mass can be taken as small m, and the radius is the distance between them. Because they are touching each other, it doesn't mean that the distance between them is zero. The distance from the center of the earth to the center of that body is actually the distance between them. From the center of the earth to the surface of the earth, the distance is actually radius of the earth, and the distance from surface of the earth to the center of the body is very less in comparison with the radius of the earth. That's why it can be ignored. So if a body is lying on the surface of the earth or any planet, then the radius of that heavenly body can be taken as the distance between these two bodies. In this condition, if we have to find out the gravitational force between this heavenly body and the body lying on its surface, then gravitational force is denoted by F, and we can use this formula F equal to G capital M small m by r square. If this is earth, then the force of attraction of the earth acting on this body is gravity of the earth, and gravity of the earth acting on a body is the weight of that body. That's why we can say this F as W also, which is weight of the body, and we can use W in place of F also. Okay, let's go to third one. G equal to capital G capital M by r square. Let's say this is huge mass, and let's say earth, and this is the radius of the earth. And if we have to calculate the acceleration due to gravity on the surface of the earth, then we can use this equation, small g equal to capital G capital M by r square. M is given, R is given, and G we know 6.67 into 10 power minus 11, and using this value we can calculate the acceleration due to gravity on the surface of the earth. Or if it is another planet, we can calculate acceleration due to gravity on the surface of that planet also. Now look at 4. This equation is a little different than equation number 3, because if we say this earth, and this is the mass of the earth, and this is the radius of the earth, and we have to find out the acceleration due to gravity at certain height, which is shown by this blue line. And at this height, if we have to find out the acceleration due to gravity, that can be represented by G dash. G represents acceleration due to gravity on the surface of the earth, and G dash represents the acceleration due to gravity at the height. I'm using G dash. We can use G1 also. Okay, this is the equation which can be used to find the acceleration due to gravity at certain height. Now let's talk about the last one 5. W equal to mg. Here W is weight and m is mass of the body, g is acceleration due to gravity. If a body is lying on the surface of the earth pulls it towards a center. And if the mass of the body is a small m, then the force with which earth pulls it towards a center is weight of the body, and weight can be calculated by using this equation. These are the equations which are used frequently to solve the numerical problem related to gravitation, gravity, acceleration due to gravity, and weight of the body. Now, why don't we use all these equations to solve the numerical problem? I want to solve numerical problem related to this equation one by one. Look at this. Calculate the gravitational force in between two objects of mass 25 kg and 20 kg if the distance between them is 5 meters. Looking at this, you can understand easily 25 kg is m1, 20 kg is m2, and 5 meter is the distance. And this is the condition what I told you. m1, m2, and distance between them is d. And if f is the question, then we can use the formula f equal to g m1 m2 by d square. Now for this, first we have to write the given. First object mass is m1, its mass is 25 kg. Second object is mass is m2, 20 kg. Distance d is equal to 5 meter, and gravitational constant capital G is equal to 6.67 into 10 to the power minus 11 Newton meter square by kg square. It is not given in the numerical problem. That's why we are writing ourselves. Now, what is the question? Gravitational force F is equal to question mark. Now, this is the equation. We have F equal to G m1 m2 by d square. Using this equation, we can solve. Capital G 6.67 into 10 to the power minus 11, and its unit is Newton meter square by kg square, and m1 25 kg, m2 20 kg, and in denominator 5 meter whole square. At this time I am writing units, but it is not necessary to write in the process of the numerical problem. We have to write units in the given, and we have to write unit at the end in the answer, but in the process it is optional. If you want, you can use, and if you feel it as a problem, then don't write unit in the process. Okay, now we are going to multiply the number with a number, and power of 10, we have to interact power of 10 with power of. For this, I want to write the number first, 6.67 into 25 into 20, and there is 10 to the power minus 11 also, and kg square is cancelled because there are 2 kilogram in the numerator. That's why Newton meter square is left in numerator. And in denominator 5 meter whole square, it means 25 meter square. Now number when multiply with number, then we'll get 3335 into 10 power minus 11. We have only 25 because meter square and meter square is cancelled here, and only Newton is left. If we divide 3335 by 25, then we'll get 133.4 into 10 power minus 11 remains same. But this is a general practice to put the decimal point after one digit. That's why I have to shift this decimal point to this position after 1, and I have to shift it to 2 digit left hand side. So I can do this by this process. If it is shifted to 2 digit left hand side, then it should be multiplied by 10 to the power 2. And so it is multiplied by 10 to the power 2. 10 to the power 2 multiplied by 1.334 gives 133.4, and that's why I am multiplying with 10 to the power 2. Now next step is 1.334, 10 to the power minus 11, and 10 to the power 2. And if same base, then we can add and subtract this power. So 10 to the power minus 11 plus 2, and finally we will get 1.334 into 10 to the power minus 9 Newton. This is our final answer. Therefore, the gravitational force between them is 1.334 into 10 to the power minus 9 Newton. Okay, let's go to another numerical problem. We are using all those 5 equations to solve the numerical problem. Okay, a man of 100 kg stands on the surface of the earth, which has 6 into 10 to the power 24 kg mass. Earth's mass is given. If the radius of the earth is 6400 km, then calculate the gravitational force between them. Look at this. a body which has very negligible mass, 100 kg is very negligible mass in comparison with the earth's mass. That's why this question is related to this condition. Earth's mass is very huge and it has very huge mass, that's why it is denoted by capital M. In comparison with this, the mass of that person is very less, 100 kg only, which is denoted by small m, capital M, small m, and distance between them can be taken as radius of the earth r. And so the equation will be F equal to capital G capital M small m by r square. But before that, I want to write the information. Mass of the earth capital M equal to 6 into 10 power 24 kg. Mass of the man small m equal to 100 kg. Radius r equal to 6400 kilometer is given, and we have to convert this into meter. That's why I'm multiplying it with 1000 and we'll get 64 having 50. It means decimal point should be shifted to this position. After 6 I am going to take the decimal point, and how many digit it is shifted to left hand side? 5 zeros and 4 means 6 digit. That's why it should be multiplied with 10 to the power 6, and then this value will be equivalent with this, and 6.4 into 10 to the power 6 meter. Very big numbers are represented in terms of power of 10, and very small numbers are also represented in terms of power of 10. It was told in previous classes also. Gravitational constant capital G, which is not given in the numerical problem, I am writing the value of this: 6.67 into 10 to the power minus 11 Newton meter squared by kg square. Now what is the question? Gravitational force F is equal to what? Now what we have this equation: F equal to capital G capital M small m by r square. In place of m1 and m2 we are writing capital M and small m, and in place of distance between them we are writing r. Okay, now taking the value this way, 6.67 into 10 to the power minus 11, and mass of the earth is 6 into 10 to the power 24 kg is given, into mass of that man is 100 kg, and divided by radius of the earth 6.4 into 10 to the power 6, and radius square means whole square. Now we are multiplying number with number and we are interacting power of 10 with each other this way. Now we are multiplying 6.67 with 6 and we will get 40.02, and here we have 10 to the power minus 11 and 10 to the power 24, same base, that's why power can be added or subtracted, and so minus 11 plus 24, and 100 means 10 to the power 2. In denominator, what we are doing, 6.4 into 10 to the power 6 whole square means 6.4 into 6.4 gives 40.96, and 10 to the power 6 square means 10 to the power 6 into 10 to the power 6. Now we are dividing this 40.02 by 40.96, and the number is 0.97705, and 10 to the power 11 plus 24 gives 10 to the power 13. And here we have 10 to the power 2, and 2 is taken in the power, and in denominator we have to write just 10 to the power 12, 6 plus 6, because this number is already used up. Now next step, 0.97705 into 10 to the power 13 plus 2 is 15, and 10 to the power 12 is if taken in the numerator, then it becomes 10 to the power minus 12 and 15 minus 12. The result is 0.97705 into 10 to the power 3. 10 to the power 3 means 1000. If this number is multiplied by 1000, then we'll get 977.05 Newton. And this is the force of attraction between the earth and a man standing on its surface. And so we can write a sentence: therefore the weight of 100 kg mass on the surface of the earth is 977.05 Newton. Okay, let's go to another numerical problem. The mass and radius of Jupiter is given 1.9 into 10 to the power 27 kg, and 71 into 10 to the power 6 meter is the radius of the Jupiter. Find the acceleration due to gravity of it. Now we have to find the acceleration due to gravity on its surface. And there is another question also attached with this: what will be the weight of an object having mass 75 kg on that planet? I want to recall this diagram. Look at this. If this is Jupiter, its mass can be taken as capital M, and a body is on its surface. It is of 75 kilogram mass, and that can be taken as a small m Later we'll do this in second part, but its radius is given r, and first we have to calculate the acceleration due to gravity according to question, and then only we'll calculate the weight of that body. Okay. For this, the given our mass of the Jupiter m is equal to 1.9 into 10 power 27 kg, radius is 71 into 10 power 6 meter, and mass of the object on its surface is 75 kg. Acceleration due to gravity small g is question, and weight of the body is also the question. Okay, we are using this value, gravitational constant g equal to 6.67 into 10 power minus 11 Newton meter square by kg square. Using this equation, g equal to capital G capital M by r square, we are continuously using those 5 equations one after another. Small g can be calculated on the surface of the Jupiter. For this, capital G is written 6.67 into 10 power minus 11, and this capital M, Jupiter, mass of Jupiter is 1.9 into 10 power 27, and radius of the Jupiter is 71 into 10 power 6 meter whole square, because radius square is here. Now we are multiplying number with number, so I want to keep the number near to each other. 6.67 into 1.9 and power of 10 to power minus 11 and 10 to power 27, and all the units are written at right hand side. Kg square and one of the kg is cancelled and remaining units are taken, and in denominator, if here we have a square, it means we can write the same twice. 71 into 10 power 6 meter, again 71 into 10 power 6 meter. When 6.67 and 1.9 is multiplied, we will get 12.673, and 10 to power minus 11 and 10 to power 27 remains same, and units also remains same, and power interacts with power. That's why 10 to the power minus 11 and 10 to the power 27, same base power is taken together, and in denominator 71 into 71 gives 5041. This is a big number, and 10 to the power 6 into 10 to the power 6 means 10 to the power 12 meter square. Now when 12.673 is divided by 5041, then we'll get 0.002539. And 27 minus 11 in power gives what? 16, 10 to the power 16. And in denominator, we have to write just 10 to the power 12 only, and 10 to the power 12 when goes in numerator, then what happens? It becomes negative, and 10 to the power 16 minus 12. And power interacts with power, and it gives the result 10 to the power 4. And 0.002539 into 10 to the power 4 means 10 to the power 4 is 10,000. We have to multiply this number with 10,000, and when 0.002539 is multiplied by 10,000, we will get 25.14 meter per second square. That's why what can we say? The acceleration due to gravity on Jupiter is this. Now again we have to calculate the weight equal to m into g, and the value of mass is 75 kg, and g just now calculated 25.14 meter per second square. When we multiply these two numbers, then we'll get 1885.5 Newton, and this is the weight of the object on the surface of that planet, 1885.5 Newton. Okay, now let's go to next numerical. Mass of Earth is 6 into 10 power 24 kg, and radius is 6400 kilometer. What will be the weight of meteor having mass 1000 kg at the height of 10 kilometer from the surface of the Earth? Now for this, we have to remember this diagram. This is Earth, its mass is capital M, its radius is r, and meteor is at the height of h. And we have to calculate the acceleration due to gravity at that height. On the surface, it is a small g. At that height, not a small g, it is g dash. We can take this as g dash also, g1 also. Now, how to solve this? First, we are writing the information given, mass of the Earth and mass of the meteor, and distance. Distance is given in kilometer. It has to be converted into meter. We are using SI system by multiplying it with 1000. In the same way, radius of the earth is also given in kilometers. 6400 kilometer can be converted into meter by multiplying it with 1000. But here we have 64 having 50. It means if we want to put this decimal point in between 6 and 4, then it moves towards left hand side to 6 digit. So 6.4 should be multiplied with 10 to the power 6 meter. Okay, now question is gravitational force is F equal to what? Here gravitational constant is not given. We have to put ourselves 6.67 into 10 power minus 11 Newton meter square by kg square, and this is the equation what we are using here. The distance is no more distance, actually radius plus height is the distance between the meteor and the earth, and that's why r plus s whole square is the distance between earth and the meteor. Mass of earth m and mass of meteor is small m. Now if we take the value g, its value is 6.67 into 10 power minus 11. Mass of the earth, its value is 6 into 10 to the power 24 kg, and small m is 1000 kilogram. And in denominator what we have, radius plus height. That's why we have to write radius as what? 6.4 into 10 to the power 6 plus height is 10,000, means 10 to the power 4, and square is given. Now we have to multiply 6.67 by 6, and it is 40.02, and 10 to the power 11 into 10 to the power 24 is taken, and 1000 means 10 to the power 3. It is written the same. And in denominator 6.4 into 10 to the power 6 plus 10 to the power 4, this is a little problem because there is positive sign in between them, plus sign we have to add, so they should be converted to normal number. 6.4 into 10 to the power 6 means 64 having 50, and 10 to the power 4 means 1 having 4 zeros, and we can add this to normal number, and when we add this to normal number 64000050 and 1 having 40, then what we get? First let's talk about the numerator. In numerator power of 10 are added or subtracted. In denominator when we add them 641 and 4 zeros are there, and it is square. Now 40.02 into 10 to the power 24 minus 11 plus 3 is 10 to the power 16. And again I am converting this big number in terms of power of 10, 6.41 into 10 to the power 6 and whole square. Now next step, what can we do? 40.02 into 10 to the power 16, it remains same, but 6.41 into 6.41 gives 41.0881. 6 into 10 power 6 is 10 to the power 12. Now we have to divide 40.02 with 41.0881, and the result is 0.974. 10 to the power 16 minus 12. 12 is in denominator 10 to the power 12. That's why it gives 10 to the power 4. 10 to the power 4 means 10,000. When this 10,000 multiplies 974, then what value we'll get? We'll get 9740 Newton. This is the weight of that meteor. That's why what can we write? Therefore weight of the meteor is 9740 Newton. Okay, let's go to next part. Now what we did, we used this equation F equal to g m1 m2 by d square in this condition shown in the diagram, and F equal to g capital M small m by r square is used in this condition shown in diagram. G equal to capital G m and r square is used in another case, and g dash equal to g m by r plus s whole square is used in another case. Lastly we use w equal to mg also to calculate the weight of the body. Thus these are the major formula which we used in solving the numerical problem related to gravity, gravitation, acceleration due to gravity, and weight of the body. I think you enjoyed this video and it helps you a lot to use this equation in proper place and to find the proper answer. Okay, this much for today. We'll meet in next class. Thank you.